Next chapter is prisms. So this is a prism. It is a portion of refracting medium. It is bounded by two plane surfaces, and these surfaces are inclined at a finite angle, and this angle is alpha, and this alpha is between the two surfaces. This angle is called the refracting angle or apical angle of the prism. A line bisecting the angle is called the axis of the prism. So this is the axis which bisects the angle. The opposite surface is called the base of the prism. So when prescribing prisms, the orientation is indicated by the position of the base. So we say the base in prism, base up prism, we say base in, base out. Base in prism, as you can see, is toward the base is toward the nose, and base out, the base is toward the ears. Base up, this is the base is up and the base is down. Light passing through a prism obeys Snell's law. At each surface, it obeys the Snell's law. The ray is deviated, as you can see, towards the base of the prism. This is the emergent ray. The net change in direction of the ray is angle D. This is angle D. This is called angle of deviation. For a prism in air, the angle of deviation is determined by three factors: the refractive index of the material of which the prism is made, the refracting angle alpha of the prism, this is the angle alpha of the prism, and the angle of incidence of the ray considered. This is the angle of incidence. For any particular prism, this angle of deviation will be least when the angle of incidence equals the angle of emergence. Refraction is then said to be symmetrical, and the angle is called the angle of minimum deviation. Angle of minimum deviation. So under those conditions, the angle of deviation is given by formula n-1 n2 alpha. So for a glass prism where the refractive index is 1.5, so if we calculate the angle of minimum deviation is equal to alpha divided by 2. This is the alpha. As you know, the alpha is the refracting angle of the prism. So the angle of deviation is equal to half the refracting angle of a glass prism. Half the refracting angle of a glass prism is equal to the angle of deviation. Now suppose this is the object and this is the virtual image. As you know, the image is formed on the same side. So this is the virtual and erect image, and it is displaced toward the apex of the prism. So the image is displaced toward the apex of the prism, while the light rays are deviated toward the base of the prism. There are two primary positions of a prism. Two primary positions in which the power of the prism may be specified: the position of minimum deviation and the Prentice position. This is the Prentice position. In the Prentice position, one surface of the prism is normal to the ray of light. So this is normal to the ray of light, so that all the deviation take place at the other surface of the prism. So on one side there is no deviation, and on the other side total deviation occurs on the other side of the prism. This is the Prentice position. The deviation of light in the Prentice position is greater than that in the position of minimum deviation. Here you can see this is the position of minimum deviation, because in the apprentice position the angle of incidence does not equal the angle of emergence. Therefore, the apprentice position power of any prism is greater than its power in the position of minimum deviation. Here there will be more power. In the apprentice position power, which normally is specified for glass ophthalmic prisms, these are glass ophthalmic prism, trial lens prisms are glass ophthalmic prisms, while so this is in the apprentice position power, it is normally specified for glass ophthalmic prisms, while it is the power in the position of minimum deviation which is specified for plastic ophthalmic prisms. For example, prism bars, these are the prism bars, so it is the power in the position of minimum deviation which is specified for plastic ophthalmic prisms such as prism bars. So here position of minimum deviation, and here it is apprentice position. If a high power prism is not used in a correct position, a considerable error will result. In practice, plastic prisms may be held in the frontal plane, as this is near enough to the position of minimum deviation to avoid significant inaccuracy. For example, so in this picture you can see the apprentice position in the minimum deviation position and the frontal plane position. So for example, a 40 diopter plastic prism held in frontal plane will have an effective power of 41 diopters, but if it is held in the apprentice position as shown in the picture, its effective power becomes 72 diopters. So that is why we say that plastic prism may be held in the frontal plane, as this is near enough to the position of minimum deviation to avoid significant inaccuracy. So frontal in case of plastic prism is near to minimum deviation, but it is far away, power is very far away from the apprentice position. Apprentice position it is 72 diopter, while in frontal the 40 diopter will be 41 diopter. Furthermore, it is not satisfactory to stack prisms one on the top of the another, because the light entering the second and subsequent prism will not be at the correct angle of incidence. The effective power of such a stack will be significantly different from the sum of the powers of the component prisms. However, it is permissible to place a horizontal and a vertical prism one in front of the another, because their planes of refraction are perpendicular and therefore independent of one another. Now the notation of prisms. The power of any prism can be expressed in various units. One is the prism diopter. A prism of one diopter, a prism of one prism diopter produces a linear apparent displacement of 1 centimeter of an object O situated at 1 meter. Object will be situated at 1 meter away and the displacement is 1 centimeter. Linear apparent displacement of 1 centimeter. When and observer see it from the opposite side. Angle of apparent deviation. The apparent displacement of the object O, this is the object, can also be measured in terms of the angle. This is the angle of apparent deviation. Under conditions of ophthalmic usage, a prism of one prism diopter power produces an angle of apparent deviation of half degree. Thus, one prism diopter is equal to half degree. One prism diopter is equal to half degree. The centroid. This unit differs from the prism diopter only if that the image displacement is measured along an arc 1 meter from the prism. Along an arc 1 meter from the prism. The centroid produces a very slightly greater angle of deviation than the prism diopter, but the difference in practice is negligible. The three previous units measure the image displacement 1 meter from the prism. Next is the reflecting angle. A prism may also be described by its refracting angle. However, unless the refractive index of the prism material is also known, the prism power cannot be reduced. So a glass prism of refractive index 1.5 of refracting angle 10 degree, it has a power of 10 diopter. So here in this case we know the refractive index, so we know the power. But if we don't know the refractive index, then we will not know the power. So 10 refracting angle of 10 degree prism, power will be 10 prism diopter, and the deviation applied will be 5 degree. It deviate light through 5 degree. Vector addition of prisms. Sometimes a patient requires a prismatic correction in both horizontal and vertical directions. This can be achieved by using one stronger prism mounted at an oblique angle or meridian. So the required power and the meridian are calculated by vector addition, either graphically or mathematically. Graphically means powers are drawn onto scale and the rectangle is completed, or mathematically using Pythagoras theorem, considering the orientation in terms of angle, like base up down, base in out. This figure shows that a 5 diopter base up prism, base up and in, it lie at 37 meridian, is equal to a 4 diopter base in prism plus a 3 diopter base up prism. Again, this is 5 diopter base up, it lies at 37 degree, it is equal to 4 diopter base in and 3 diopter base up. Next topic is Rayleigh prism. The Rayleigh prism is another application of this principle. It consists of two prisms of equal power which are mounted one in front of the other in such a way that they can be rotated with respect to each other, and the resulting power is indicated on a scale on the rim of the instrument. Here in this picture you can see that the two prisms of equal power. This picture you can see the two prisms, they can be rotated with respect to each other, and the resulting power is indicated on a scale on the rim of the instrument. In the inner picture you can see in this picture you can see that a Wesley prism is used in conjunction with a Maddox rod to measure porias and is included in the refractor heads used by many optometrists instead of tri-lens box. So Wesley prism is used in conjunction with a Maddox rod to measure porias. What is poria? Poria and tropia both are deviations, but tropia is present every time and porias are present when it is not always present, but sometimes present when we do the uncover test, when the fusion is broken. Well, seriously, I don't know how it is used to measure porias. If someone knows, tell me in the comment section. Now we will discuss interpretation of orthoptic reports involving prisms. So armed with the knowledge that we know that one prism diopter is equal to half degree, the orthoptic reports become intelligible to the clinician. The orthoptist measures the angle of squint by two methods, using the synoptophore and by the prism cover test. Using the synoptophore, the orthoptist measures the angle between the visual axis of the eyes in degrees. Plus signifying esotropia and minus signifying exotropia. The orthoptist report reads the synoptophore. For example, she will write synoptophore without glasses of plus 20 degree, which means an esotropia of 20 degree. She also measured the angle of squint by prism cover test. The alternating cover test is performed placing prisms of increasing strength before one eye until movement of the eye is eliminated. So the alternating cover test is performed and prisms are placed of increasing strength before one eye until movement of the eye is eliminated. The result is expressed in prism diopter, eso signifying esotropia, exo signifying exotropia. The report reads PCT, which means prism cover test, is equal to distance, which is measured for about 6 meters. ESO means esotropia plus 40 diopter, means plus 40 diopter lens is used. So these two statements express the same angle of squint, 40 diopter and 20 degree. Both represent the same angle of squint. Now, diagnostic prisms. The uses of prisms are used for diagnosis, for the assessment of squint and heteroporia, measurement of angle of squint and heteroporia objectively by prism cover test and subjectively by Maddox rod. To assess likelihood of diplopia after proposed squint surgery in adults. In adults, before performing squint surgery, we do prism cover test. For example, if a patient has 60 diopter of squint, we place 60 diopter of prism, so the eyes are aligned. And if the patient has diplopia, so we correct the whole of the squint, 60 diopter. If the patient has diplopia, it it tell us that after the surgery, after the squint surgery, the patient will have diplopia if we correct the whole 60 diopter of the squint. So if, for example, the patient has 60 diopter of squint and prism cortex tell us that after 40 diopter the patient feels diplopia, then we don't move ahead of 40 diopter in the squint surgery. We only correct up to 40 diopter. So it tells us how much we should correct, we should do correction in the squint surgery. Number 4 is measurement of fusional reserve. Increasingly powerful prisms are placed before one eye until fusion breaks down. So this is very useful in assessing the presence of binocular single vision in children under 2 years of age. Number 5 is the 4 diopter prism test. This is a delicate test for small degrees of esotropia called microtropia. A 4 diopter prism placed base out before the deviating eye, causing no movement as the image remains within the suppression scotoma. But when placed before the normal eye or the fixing eye, movement occurs. So in the 4 diopter prism test, the prism is placed base out, the deviating eye there is no movement, and fixating eye movement occurs. Assessment of simulated blindness. If a prism is placed in front of a seeing eye, the eye will move to regain fixation. So if a patient tells us that he cannot see, place a prism in front of his eye through which he said that he cannot see. If the eye move, he is simulating blindness. He is functional. So another use is therapeutic prisms. So one was for diagnosis. For diagnosis, forms of prism used in the assessment include single unmounted prisms, the prisms from the trial lens. For diagnosis, these lenses are used. Single unmounted prisms from the trial lens set, and prism bars. These are bars composed of adjacent prisms of increasing power. So next is therapeutic prisms used for convergence insufficiency, and the second is to relieve diplopia in certain cases of squint. So therapeutic prism used for 2 purposes. Number 1 is convergence insufficiency. The commonest therapeutic use of prism in the orthoptic department is in building up the fusional reserve of patients with convergence insufficiency. The prisms are used base out during the patient exercise period. During the patient exercise period only. They are not worn constantly. And the purpose is to relieve diplopia in certain cases of squint. These include decompensated heteroporias, small vertical squints, and some paralytic squints with diplopia in the primary position. Prisms are reserved for those patients for whom surgery is not indicated. Forms of therapeutic prisms. One is temporary wear prisms and one is permanent wear prisms. Temporary wear prisms used in the treatment include clip-on spectacle prisms. Clip-on spectacle prisms for trial wear. An improvement on these are the Fresnel prisms. They are available in all powers implied clinically. A Fresnel prism consists of plastic sheet are parallel tiny prisms of identical refracting angle. As you can see, the overall prismatic effect is the same as that of a single large prism. The sheets are lighter than a glass prism and can be stuck on the patient glasses. As you can see in this picture. And there is permanent incorporation of a prism into a patient's spectacles. It can be achieved by decentering the spherical lens which is already present. The spherical lens of the glasses which a patient use, we just decenter. Alternatively, prisms can be mounted in spectacles. Now, notes on prescribing prisms. Generally, when prescribing prisms, the correction is split between the two eyes. As you can see in this picture, to correct convergence, the prisms must be base out. The base is towards the ears. The apex is towards the nose. For example, this is 8 diopter, base out, right in, left. To correct divergence, the prisms must be base in. For example, 6 diopter, base in, right and left. So the eyes are in divergence, as you can see. So the prism will converge the light. Now, to correct vertical deviation, like for example here the patient is hypertropia. To correct vertical deviation, the orientation of the prism is opposite for the two eyes. For example, for 2 diopter, base down in the right eye. As you can see, in the right eye it is base down, while in the left eye it is base up. This is 2 diopter, base down, and this is 2 diopter, base up. Base up, left eye for hypertropia. So this patient is actually hypertropia in the right eye. So in the right eye we will use base down, and in the opposite eye we will use the base up. So this is hypertropia. This patient is right hypertropia. We will use base down in the eye which is hypertropia. So the apex will always be towards the deviation. So you should remember only this, that the apex of the prism must always be placed toward the direction of the deviation. For example, right hypertropia, so the apex in the right eye should be upward. Prisms in optical instruments. Prisms are commonly used in ophthalmic instruments as reflectors of light. That they are designed and oriented so that total internal refraction occurs in the prisms. Instruments in which prisms are used include slit lamp microscope, the applanation tonometer, the keratometer. Prisms give greater flexibility in dealing with an image than do mirrors. There are many possible systems available, which you can see in the pictures. Here the prism is used for the deviation is 90 degree and the image is inverted at 90 degree. Next is poroprism. You can see the deviation is 180 degree, image inverted but not transposed left to right. This is poroprism, image inverted 180 degree. is dou prism. There is no deviation. Image inverted. Here you can see the image is inverted. Here the image is up, here the image is down, but not laterally transposed.